Okay, so sketch the graph and state the domain. And I will just say sketch the graph. So you have to know all the pieces. So what's the first thing I do?
Factor the top.
Factor the top. So factors of 6 have a difference of 5.
6 and -1.
So 2x. How about -6?
Yeah, sorry.
Okay, and then I've got to factor at the bottom. So factor out an x squared. What just happened? Factor an x squared. Factor. I'm trying to write too far up in the corner is what I'm trying to do. Okay, so I have x squared. Morning, Cooper. And x minus 2, -1. So it's going to x minus 2. So I get x minus 2 and x plus 1, x minus 1. Yes?
Yeah.
Okay, so then what?
Domain.
Okay. We'd reduce first, right? But is there anything to reduce?
No.
Okay, so the domain can't be -1, 2, or 1. How about 1 or 2?
Yes.
Just trying to save room because I know I'm going to need it. Okay, then what? Bless you.
Bottom two.
Nope.
Bless you.
Bless you. How about x-intercept?
Oh, okay.
When do you do your x-intercepts?
After my asymptotes.
Oh, okay, we can do that.
That's fine.
I did you.
You do them after? Okay, we'll do them
No,
after.
I know before.
Oh. Okay, x-intercept. So how do I find my x-intercept?
Set the numerator to equal 0.
So 2x plus 1, x minus 3 equals 0. So we write them as a point, right? So I get -1/2, 0, and 3, 0. Then what?
Y-intercept.
And how do I find y-intercepts?
Put zeros for all the x's.
So I'd have 0 minus 0 minus 3 over 0 minus 0 minus 0 plus 2. So 0, 3/2. Next.
Vertical asymptote.
How do I find those?
Set the denominator equal to 0.
So x minus 2, x plus 1, x minus 1. So x equals -1, 1, and 2. Next.
Horizontal asymptote.
How do I find those?
The degrees.
So I have 2 and 3. So my inequality between them,
The greater than or less than?
less than. Because left compared to right. So if it's less than,
Then it's 0? No. Yeah?
so it's y equals 0. Okay, then you were supposed to put all that on your graph, right?
Mm-hmm.
Okay. So x-intercepts at -1/2 and 3. And y-intercept at 3/2. Vertical asymptote at -1. It's awfully curvy. 1 and 2. And horizontal only affects the outside at 0, right?
Mhm.
Well, there's a lot of blank spaces there, isn't there? Like, we probably could figure out that this chunk right here went here, here, and then up here. Yes? And this piece probably goes next to this asymptote through here, up, and then back down. Because remember, asymptotes are like a magnet. But we don't know about the left-hand side or that little sliver in there, do we? So what we need to do is something called interval analysis, and you okay, so interval analysis. Intervals are made by x-intercepts and vertical asymptotes. So that's how you get the intervals. Do you remember my little person that I said walks across it's like skipping down the street, right? Always starts at -infinity. And then where's our first break?
1,
-1. Then I leave -1. And I go to
1.
-1/2. Because the x-intercept. And then I leave -1/2. And now I go to 1.
2.
And then 1 to 2.
2 to 3.
2 to 3. And then 3 to +infinity. So when we do this, we should get between -1 and -1/2, we should get a negative, shouldn't we? If it goes by what we did. And then between 1/2 and 1, we should get a positive if we plotted our points right, because that's what our graph shows us. It shows us it's negative and then goes positive, doesn't it? We should get between 2 and 3, we should get a negative, and then it should go positive if we graphed everything so far right. So what we have to do, and I do expect you to do this on every problem, even if you can tell what it's doing, because it gives you a check for your work. So give me a number between -infinity and -1. -2. Just give me any number. So just write it down so I know what you used, and then throw it in. I think it's easier to throw it in the factored reduced, because then it's just multiplication of negatives and positives. Okay? So if I throw -1 into 2x plus 1, I get a what? I don't care what the answer is, positive or negative. All right, sorry, -2, sorry. -2, I'm plugging right in here. So negative 2 would be negative 4, this would be a negative, wouldn't it? Okay. X minus 3, a negative 2 would make it negative. And then I'm going to go to the bottom. Negative 2 would make my first quantity negative, my second one negative, and my third one negative. So the whole thing is going to be what? Negative, because I got 5 negatives, don't I? So that means the graph is down here. Negative means it's below the x-axis. So you just put like a minus there. So I need a number between negative 1 and negative 1/2.
Wait. Oh, that is negative 1/2.
Negative 3/4.
Negative 3/4. Again, I don't care what the number is, guys. I just care if it's positive or negative. That's it. Okay? So negative 3/4 times 2 would be negative 3/2. Is that bigger or smaller than 1? Is 3/2 bigger than 1 or smaller than 1? Bigger, so it's going to be negative, isn't it? Okay? Then negative and a negative is going to be a negative. Negative and a negative is going to be negative. Negative 3/2 is bigger than 1, so it's going to be a negative. And then a negative and a negative is a negative. See, I don't even care what the number is. It's just my number sense. So 5 negatives would give me a negative, which we already said had to happen from where our points were. So the next one better be a positive. So are we going positive?
0.
Well, we already know what's happening at 0 because we placed it positive. So let's go off 0. How about 1/2? Okay. It should come out positive because 0 came out positive. But if we did our math wrong, like if it was supposed to be a negative, then that wouldn't show up. Okay. So 1/2. Well, that would be a positive, negative, negative, positive, negative. Right? And that comes out to be a what? What's that come out to be? A negative. What's wrong with that?
It needs to be positive.
It needs to be positive. So should I go up and check out my y-intercept?
Yeah.
And look what I did and you guys didn't catch. Look at your y-intercept.
Negative.
It should be negative, shouldn't it? So this, I really messed up because now it's like, that should be there. So then wait a second, this one should have probably been positive, shouldn't it? Because don't I have to go through a 0? Yes? So that means I need to check this x-intercept. I'm pretty sure it's negative 1/2, aren't you? If I FOIL out, hopefully I didn't make a mistake there. That'd be negative 6 plus 1, that'd be negative, right? So that would be negative 1/2. So I'll come back and check my math on my interval here. That would be 2 times negative 3/4 would be negative 2/3 plus 1, which would still be negative, yes? Okay. And that would be a negative, and this would be a negative, and this would be a negative, and this would be a negative. We got to come back to this, don't we? Let's go on and we'll come back. We found our mistake, this one. But we got to figure out this one. It's probably something stupid that we're just not seeing. Okay. So between 1 and 2. – 3/2 work? So that's going to be a positive, a negative, a negative, a positive, a positive. Is that right? Because 3/2 is bigger than 1. That's a positive. 3/2 is less. That's a negative. 3/2 is less. Yep. So the whole thing is going to be what?
Positive.
Positive. Okay, between 2 and 3. 5/2?
Maybe 2.5.
Yeah, 5/2.
Why not just do 2.5?
Because we need to remember to be working in fractions more. Okay, so I'm pretty sure that's bigger than everything up there, yes? Oh, except what? It's not bigger than that, is it? It's between 2 and 3. Is it not bigger? It's not bigger than 3, is it?
Right.
So then we'd have a plus, minus, plus, plus, plus. So the whole thing would be minus, and that's what we said it should be. And then between 3 and positive infinity. Now what?
4.
4? Well, 4 is bigger than everything up there, so it's what?
All positive.
So it's positive. This middle section's bugging me. Because okay, so we got a graph, right? So this should be down here. And this little piece was positive. So we don't know how far it goes down or anything like that, but we know it goes down, doesn't touch the x-axis and goes back up. Because of this positive right here. But this middle chunk is really bugging me. Do you all understand why I'm like, it should go down and not go up? Does that all make sense?
Mm-hmm.
But why? Should go like that. But if it goes like this should be a positive. And negative 3/4 is definitely between negative 1/2 and negative 1. Negative 3/2 is definitely larger than 1, so that'd be negative. It'd be negative because that's a negative. It'd be negative here, negative here, negative here. I'm going to have to go back and find what we did wrong. I also want to show you that we can put these in our calculator so you can check how they look. Well, on your test, you're not going to have a calculator. We're going to do the slant asymptote before I show you, but I'm writing this one down. Okay. We'll figure that out. I'm going to go back later and figure that out. So that's really bothering me. Oh, that's a better picture. Okay. Next, slant. Do you guys remember when it was a slant? It was rule 3 on the horizontal asymptote.
When the degree of the numerator is 1 higher than the degree of the denominator.
Yes. Okay, this is the but that we wrote off to the side when I gave you those already. At C plus, it says if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote, but if it is greater by exactly 1, there is a slant asymptote, also known as an oblique, found by using long division.
Did you
So,
put that down already?
yes, you should have that written down
I think I don't know again. Did you put-
already.
I don't-
Hmm?
I said I think I put it down, but I wanna double check.
Should be your third rule. Should be the but.
Yeah.
Okay. So that is what it will look like. Okay, this slant asymptote is y equals mx plus b. That is why it's only exactly 1, because every time you do the division, how much do you go down? 1. So that's where you're going to get this. I do not care about the remainder. You get your y equals mx plus b and you stop. No need for the remainder. Okay, I don't care about it. Get the y equals mx plus b and stop.
If the only there's a slant.
Yes, like normally you would finish. But when you're using it for slant, you don't need to even acknowledge it exists. Good?
Yeah, it's y equals mx plus b, isn't it?
Mm-hmm. Y equals mx plus b. So that you have your y-intercept. That's a b, not a 2. You'll graph your y-intercept and then count your slope.
Okay.
I will tell you, since these are sketches, counting your slope is kind of hard. The easiest way to graph it is an x-intercept and a y-intercept. So x-intercepts, we know y is always 0. And so you just plug a 0 into it. And y-intercept, we know that x is always 0. And so then you can get your x and y intercept and have a better graph. Okay, so we're going to sketch that. You want to just go to a hard one?
Sure.
Oh. I don't know really hard, but I don't want to go to a very basic one. Oh, this is a good one. Okay, so I have y cubed minus 8 over x squared plus 1. Okay, so the first thing we do is factor. The top is the difference of cubes. And I've given you that one before, but cube root of x cubed is x, same sign. So minus. Cube root of 8 is
2.
2. So that's your first part. And now this x is my first thing, negative 2 is my second. Got it? Okay, first thing squared. X is my first thing, 2 is my second thing. First thing squared. X squared. Opposite sign.
Plus.
Multiply the 2 together. 2x. And always square the last, which will always be positive because a negative squared is a positive. Over x squared plus 1, because we can't factor that, can we? Now, I will tell you on the numerator that x squared plus 2x plus 4, that is never real solutions, ever. They're not real zeros, because factors of 4 cannot add to 2. They are not real solutions, ever. Ever. Okay, so we simplified, then What do you want to do? You want to do vertical asymptotes first?
Sometimes I do like domain.
Oh, you can do the domain. I don't care. You guys tell me. Domain.
It just cannot equal 1 or negative 1, right? Then what is it?
How do you find it? Denominator equal to 0, right?
Yeah.
So that'd be x squared equals negative 1. Is that a real solution?
No.
Nope. So it's all real numbers? This might look kind of funny when we're done with this graph.
Intercepts.
So x-intercept. Now remember I just said that x squared plus 2x plus 4 is never a real solution, right? So I'm just going to put x minus 2 equals to 0. So my x-intercept is 2, 0. Y-intercept. 0 minus 8 over 0 plus 1, which would be negative 8. So 0, negative 8. I didn't mess up my negative that time. Vertical asymptotes. X squared plus 1 equals 0, but x squared equals negative 1, so that is none. Horizontal asymptote. Degree of the numerator is
3,
denominator is
2,
so 3 is greater than 2, so the answer is none there, right? But what?
slant.
There is a slant. How do I find a slant? Long division. Remember to fill in your zeros. Oops, not plus 8. It is minus 8. How would I do that the right order? None of you said you're putting the wrong thing outside. Okay, can I put x squared into negative x?
No.
No, not without putting x to the 1/2, and we're not doing that. So my equation is just y equals
X.
x. So y equals x is
It's 1 over.
that identity line, isn't it? Okay, so let's put everything on our graph. I always put everything on my graph before I do my intervals. I think it's easier to see them. You don't have to. I just think it's easier. Okay. So does yours look like mine? Okay. So now we need to do interval analysis. So remember, intervals are made by x-intercepts and what kind of asymptotes? Vertical. X-intercepts and vertical. That's it. Okay? So negative infinity to what?
1. 0. 2.
2.
I meant the first time.
Because x-intercepts and vertical asymptotes. 2 to what?
Infinity.
Mm-hmm. So let's do like -6 to make this obnoxious. Well, -6 cubed. On this one, I'm putting it back into the original. Just because. I think it's easier. -6 cubed is a negative, minus 8 is a negative.
Yeah.
And then -6 squared is a positive, plus a positive is a
Positive.
positive. So the whole thing is going to be
Negative.
negative, which there's our -8, right?
How do you figure out what it is again?
Hmm?
How do you figure out if it's negative or positive?
Well, there's one negative, one positive. Or
Okay,
how I'm
so
plugging it.
then on interval analysis where it was 1, 2, and we did 3 halves,
Mm-hmm.
or no, 2, 3, and we did 5 halves. It
Mhm.
was plus, minus, over, plus, plus, and it was a negative.
Plus, minus, over,
Plus, plus, plus.
because there's an odd negative. Remember, odd number of negatives makes it a negative.
Oh, okay.
Okay. So then 6. Well, I'm pretty sure that we would have a positive because 6 cubed is definitely bigger than 8, yes?
Mm-hmm.
And a positive. So the whole thing is positive. So that means we're down here and up here. Now, the problem with this is I have to go near this asymptote, don't I? But this asymptote does what? Like, it goes forever, right?
Yeah.
So if it goes forever, like our instinct is to make this look funny, but it goes like this, and then eventually can it go over like this to this one? Yes. But it looks funny because we don't have exact paper. Does that make sense what I'm saying?
Mm-hmm.
So x cubed minus 8 over x squared plus 1. So let's look at it. So how do I graph things in my calculator? I put it into what?
Y equals
Y equals. So y equals, and you need to put numerator and denominator into parentheses, as you will mess it up. Minus 8, right? Divided by x squared plus 1.
Where is the x in there?
Right next to alpha. Okay, I'm going to zoom 6 just to get me right around the origin. That's really weird, isn't it? Do you see the slant asymptote on there?
Uh-huh.
If you want to graph the slant asymptote, you could. Just put an X so you could see it. But remember that X it's not there, right? So nothing we did could have told us what it actually looked like down at the bottom, is there? There's nothing we could have done.
So do we graph it like that?
Yeah, go ahead. You won't have ones that look that funny. Like most of yours would just be further curves, like bigger curves. So to graph them in your calculator, you can check if you're right. So let's go back to the other one we did. And if you want to leave it on there, you're like, I need to go back and work. Remember, if you go on that equal sign and hit enter, it unhighlights it. So you can leave it there for later. So the first one we did was, what was it? 2x squared minus 5x minus 3 divided by, and when you do this, don't put what you simplified, because if you simplified wrong, is it going to be wrong anyway?
Mm-hmm.
Yeah, so put that original 2x squared,
Do you want us to put this in there? Or
if you want, that's up to you, minus x plus 2. Okay, again, I'm going to hit zoom 6, just make sure I haven't messed with it any. Okay, so it does go from the top to the bottom, and we said that's what it should do, right? So something in our interval analysis, I will have to look at it. We did wrong. You see that little piece of red right here? Let me see if we can see more of it. So we need to do like a max 10 of like 50. Now, where'd it go? Oh, I did X. I didn't want X. I wanted what? Y. Like, where'd it go?
I'm gonna put the back at 10.
Oh, I put it at 1. Okay. Now graph.
You put it at 5.
I thought I put, this thing does not always get my zeros. Okay. Is that what our graph looked like? Yes? Okay, so you can check them and make sure you're getting them right. You will not have a graph on you will not have a calculator on the test. But
we're already having another test?
yeah, we're just having a test over this stuff.
Okay.
Because when you put this on another test, you can put one of these. Like on your final, there's 2. Because,
Can't we like go to the zoo to get out of time?
no. Okay, do we need to do another slant? Or do you guys just want to like find the slant? What do you want to do? Do you want any more with the slants?
No.
Doesn't seem that hard.
Okay, it's not. How do you find a slant?
Long division.
Long division. And I don't know why this slide twice. Oh, because it basically says that.
Is that it?
Yep.